Yes, please. A very good evening. And good evening to online students too. Yes, please reveal your faces fast and also with a little smile. Keep keep a smile on the face, okay? If I teach well, have a smile for that reason. If I don't teach well, smile with the hope that it'll improve. Okay. But the rule is that keep smiling. So fine, first write the thoughts for the day. Please don't talk. Once in the classroom, attend to the purpose of the lecture. Believe you can and you are halfway there. So first have the confidence to crack the examination, then it becomes easier. Modern technology owes ecology an apology. Those who think education is expensive, try ignorance. It means in the long run, ignorance will cost you more, okay? So basically, we are saying you have paid the right fee. Okay. This is on the lighter side. I have nothing to do with that, okay? The whole purpose of education is to turn mirrors into windows. Is this understood? Good for essay writing. That when you look into mirror, you see your own self. You have not much perspectives in life. Education provides you the window to the whole world. New perspectives, new learnings. The next one is little philosophical in nature. Good for paper on ethics and essay writing. All sins are attempts to fill voids. Is this understood? We do wrong things in life for the reason that we have voids in life. Try filling voids in your life through good education, through good relationships, but relationships after the selection. One more on nature. Nothing that is natural is disgraceful. It means whatever Mother Nature has given us, it's all good. It is all with a purpose. Even earthquakes are important. Volcanism is needed. No, cyclones are needed. If they were not there, the earth will not continue as a planet. So it is mankind which has added wrong things to nature. And that is why we have the problems related to climate change, global warming. No? Fine. So now let's go to our geography lecture. Please check your notes of the last lecture. We mentioned about IMC, International Meridian Conference. No? So let me tell you the plan for this lecture. In the next about 40 minutes time, we'll understand two concepts of angles, one called latitude and the other called longitude. These two angles will act as the address for a place of the earth. And on the basis of these two angles, we'll have two lines called parallels and meridians. The network of these lines is what we call as grid system on the globe. Once this is understood in the next 45-50 minutes time, we'll go for using the concept of parallel to divide the whole earth surface into different zones. And then we'll go for some related concepts from mathematics to learn more about these things. And finally, we'll talk about the translations or transfers, the convergence of these latitudinal and longitudinal angles into linear distances. Okay, basically, there would be related dimensions, which you'll understand as we go further. So, we'll develop the concept called latitude and longitude. And what is the last point of the previous lecture? You had to get reminded. If you remember in the last lecture, we said that it is good that our earth is not perfectly spherical, because the scholars who were sitting in that conference of IMC 1884, it became easier for them to decide the position for the poles, and the second, to decide the reference line for the angle called latitude. Only one thing nature had not decided, that was the reference line for east-west distances. And there we had a lot of hot debates, but finally we decided the Greenwich meridian as our reference line. Okay. Now, to understand the concept of latitude and longitude, I would suggest you that you think of an apple in your mind, and along with the apple, you have a knife also with you. Okay. So what we'll do is, first I'll draw the apple on the board. Apple, I'll assume as a spherical body. Okay. Though I know apple is not sphere, but we'll assume it as spherical in shape. So for all my lectures till the end, apple would be often used in the classes. And whenever I say apple, it is a spherical in shape and it is representing my earth. So when you represent that spherical shape on the board apple, it would become a circle. And in your notebook also, it will become a circle. Both are two-dimensional. So please make a big circle to show earth the way I do it on the board. Please start with me. So please draw your apple in the notebook. I repeat, what is the task? In the next 45 minutes, you'll understand four things: latitude, longitude, parallels, and meridians. To have an easy understanding, I suggest think of an apple as spherical in shape, and this apple is representing my earth. Now, with the help of a knife, let us mark the central portion of the apple so that we understand the plane called equator. Remember, I told you last time that where the earth is bulging out in the middle portion will act as a reference. And today this reference will be called as equator. We'll understand what is the technical definition of it. What you do is you just draw a curved line in the center to represent the middle portion of the earth. Now with the help of a knife, let us mark the shape of a slice on this apple. We'll not cut it, we'll just first make the shape of a slice. So what I do is, I run the knife from the top to the bottom. You also do that way. And I run it on this side also. So I make the shape of a slice. So is everyone okay with this? That we have taken an apple, I have marked the central portion with a little curved line where the earth is bulging out, and then I have given the shape of a slice on this apple. Now let's visualize taking out the upper half of the slice. Means let's suppose I have cut this much portion deeper and have taken it out. The moment you take out the upper half of the slice, when you take it out from the apple, you'll be able to locate the seed of the apple. If apple is my earth, the seed of the apple will represent. You don't answer, I'll answer. Okay. See, certain questions are for myself only to remain motivated. No. So it sounds as if I'm asking you, I'm not asking you a question. When I ask you a question, I'll make it clear that this is for you. Okay. This is the rule for all the classes. Because I've mugged up the lecture and you are making it wrong. Now see, when you take out the apple, you'll be able to locate the seed of the apple. The seed of the apple will represent center of the earth, not the core. Core is too huge, no? And core, other teacher will talk about. I really do not know much about the core. So let's say this is the center of the earth. I represent it by C. Now you do the same. So everyone is having an apple where half slice is taken out, okay? And you are able to locate the seed of the apple. If apple is my earth, then the seed location is the center of the earth, right? Now, what is the task for this part of the lecture? We have to locate a point on the earth surface, a place on the earth surface. It means we need an address to reach to a place. When you have to locate a place on a spherical surface, like a ball or like a globe, you need two angles. One is called latitude, the other is called longitude. And as a rule, we write the latitude of the place first, and then we write longitude. This is as a convention. So let's say I'll be locating a place P on the earth surface. Now, since we are doing this lecture in northern hemisphere, so I assume this place on the north of the equator. So let's say this is the place which we would wish to locate today. You also mark a similar place, right? So I need the address for P. And there are two components of the address. First component is latitude, and the other component is longitude. So whenever you have to mark a place or you have to reach a place of the earth surface, the surface of a sphere, you need two angular measurements. I repeat, latitude and longitude. Now, what is broadly speaking latitude here in a broader perspective? Latitude, as I said last time, it is the angular distance of a place north or south or some reference line. And you have already been told in the previous lecture that the reference line was chosen by the scholars of that conference in the middle of the earth, where the earth is bulging out. Okay. Now, this is that portion where I said earth is bulging out. So let us mark some points on the middle of the earth surface. So let's say this is one point which I mark as A, and this is point B. And A and B are where? They are on the earth surface in the middle of the earth. So everyone should be clear about 4 points of the diagram. C is the center of the earth. A and B are the points on the surface of the apple, right in the middle of the earth, the middle of the apple. Is that okay? And P is the point which is given to us for the earth surface. And what is the task? We have to develop an address system for this place P. And address has two components, latitude and longitude. Now, since latitude is the angular distance of a place north or south of the middle of the earth, so what I suggest is that let's join C with A. Please, you do that in your diagram. I do it on the board. Connect C and A. Now, before I go further, let's have one clarification. This line segment CA on the board as well as in your notebook appears to be little inclined. Yes, please. It appears to be inclined because my board is two-dimensional and even your notebook is two-dimensional. But most of you understand that CA in apple is not inclined, it is horizontal. Is everyone clear with that? So this is one first clarification a few students may need, that CA is a horizontal segment. Yes or no? It is not inclined. It means I represent this line segment with my left hand. Let's suppose this is C and this tip of the finger is A. So even if it appears to be little inclined in the diagram, but it is not so, it is like this. Is it okay? See, when you have taken the half slice of the apple, this portion is horizontal. Yes or no? So CA is a horizontal plane. This is the plane which will become our reference for angular distance north or south. So it means very soon we'll be understanding CA representing equatorial plane of the earth. What is equatorial plane? If my left hand is the earth, by equatorial plane I mean that imaginary plane which cut the earth through the middle into two halves, northern hemisphere and southern hemisphere. So is everyone okay with C as the equatorial plane? C as the reference plane for measuring north or south distances. Now, I want to measure how many degrees P is away from CA. And since we are doing this lecture in northern hemisphere, so I have chosen the point on the north of the equator, right? So I wish to show how many degrees P is north of the middle portion of the earth, what is called equatorial plane. So if this hand represents the way I'm holding it as the equatorial plane, this is C and this is A. Let's say this tip of the finger is P. So I put my right hand over left hand and I open, just to show the diagram, I say P is these many degrees on the north of the equator. So this is C, this is A, and this is P. This distance is what we call as latitude. It could be on the north or it could be on the south. If I was doing this lecture in Sydney for Australian students, for Australian Civil Services examination, then I would have taken a point on the south of the equator and I would have been telling my students that this is the latitude. So, to get this angle, which I have shown with my hands, can I say that I'll get that angle if I join C and P? Yes, please. Join P and C. Now this angle, let us say, is X degrees. And it is on which side? It is on the north of the equator. So what is the latitude of P? Latitude of P is, yes please, X degrees north of the equator. So let's understand latitude little more comprehensively. If someone has a question that, sir, how much could be the maximum variation of latitude? So I say, if this is C, this is A, and this is P, I put P over A. Can I say at this moment, there is no distance of P from this horizontal plane? So latitude is the angular distance north or south of the equator, the equatorial plane. At this moment, this is 0. I can take it maximum to the north like this. When P reaches here, it is 90 degrees north. And 90 degrees north would be called as north pole of the earth. And the second possibility is that I say take it from 0 degree to 90 degrees south. This 90 degrees south would be south pole of the earth. So is the class okay with this? That latitude varies from 0 degree to 90 degrees north or south. 90 degrees north is north pole and 90 degrees south is south pole. So is the class okay with this? That latitude is the angular distance of a place, north or south of the equator. Equator is the plane which is in the middle of the earth, where earth is bulging out. And we decided this reference in the last lecture in that conference of 1884. Now, if this is okay, now just keep looking at the diagram. Can I say, if someone tells you the latitude of a place P, you will not be able to reach to that place. Yes, please. By just knowing the latitude of a place, can you reach there? Certainly not, because the diagram tells you indirectly that there are thousands of points on the surface of the apple everywhere here, which have the same latitude as that of P. Is this okay for everyone? That we cannot reach P by just the knowledge that P is X degrees north of the equator, because this is not a complete address. The reason is that there are thousands of points on the Earth's surface all around the Earth here, which have the same latitude as that of P. It means it is something like that you live in Calcutta and you are talking to your friend in Delhi, and you tell that friend, I live in Calcutta, next time when you are there, please do come, and you repeat this sentence 10 times and then switch off the phone. You have given your friend a beautiful address that I live in Calcutta, do visit me next time. It means you have made it clear that you don't want the friend to visit you, right? Because you have given the address that I live in Calcutta. It's something like that, that you cannot reach to the precise location P. Now, if the class understands that there are thousands of points here which have the same latitude as that of P. Now, before I go to the second component of the address, if we join, mind this, if we join all the points which have the same latitude, then we get a concept of a line called parallel. So latitude is understood as the angular distance north or south of the equator, and it varies from 0 to 90 degrees on the north or south. Now I develop a concept called parallel. And what is parallel? A line connecting places with same latitude. Is okay? Now, those who are not getting it, I give an example. Now I can make a technical definition of equator. Keep your eyes on the board. Can I say equator is a line which joins places having 0 degree latitude? So see here, this is C, this is A, this is P. What is the latitude of P now? 0. If I rotate my right hand like this, wherever the tip of the finger goes, it is tracing the line called equator. See here. Understand fast, I can't do more. So this line on the globe is what? Equator. And it is what? 0 degree parallel. Okay. So we understood two things. I repeat, latitude as an angular distance north or south of the equator, and parallel is a line connecting all places of the same latitude. For example, 0 degree parallel is called equator. Now someone would have a question that, sir, why do you call parallel as a parallel? Means why this line of latitude is being called as parallel? The answer is that when you draw the lines of latitude, for example, 0 degree, then you draw 10 degrees, 20 degrees, they are going to run parallel to each other. Since all lines of latitude would run parallel to each other, so these lines are called parallels. Now someone may say, sir, on the globe, these are not lines, these are circles. Very right. Remember, on the globe, all these lines, all these parallels will be circles. But since most of our discussions are on the board or in the notebook, so we can treat them as lines. But in reality, the equator is a circle, or all other parallels are circles. Okay. But very often we will use it on line. Though we know in reality on the globe, they are going to make circles. So if this is all good, let's write the notes for latitude and parallel. Then I'll take you to the second component. So please write. What is latitude? Latitude is the angular distance. Latitude is the angular distance measured north or south of the equator. Measured north or south of the equator. Now be on the board for the next. See here, whatever you write in the next point would be based on this diagram. So whatever you write, keep relating to this sketch. So write the next point. We can project a line. We can project a line from a given point, and take a pause. What is the given point in the diagram? P. So within bracket write P. From a given point P on the Earth's surface. From a given point P on the Earth's surface to the center of the Earth. And what is center? C. So replace that to the center of the Earth within bracket C. So I repeat the sentence you have written. We can project a line from a given point on the Earth's surface to the center of the Earth. And what is this line which we have just written about? It is line called PC. Right further in the same point. the angle between this line is PC, the angle between this line, that is PC, and the equatorial plane, the angle between this line and the equatorial plane. Now just take a pause here. What is equatorial plane? CA. This line is representing equatorial plane. So write within bracket CA. The angle between this line and the equatorial plane is a measure of latitude, of the given point P, is a measure of latitude of the given point P, full stop. Now write next point. Latitude varies from 0 to 90 degrees north and south. Next point, please. Latitude varies from 0 degree to 90 degrees north and south. Latitude varies from 0 degree to 90 degrees north and south. Now you write the next concept, parallel. Please write parallel is a line connecting all points of the same latitude. Parallel is a line connecting all points of the same latitude. A line connecting points of the same latitude. Then right, next sentence. Lines of latitude are called parallel. Lines of latitude are called parallels as these lines run parallel to each other. Lines of latitude are called parallels as these lines run parallel to each other. As these lines run parallel to each other. Lines of latitude are called parallel as these lines of latitude run parallel to each other. The right next point. 0 degree parallel is called equator. 0 degree parallel is called equator. So we have done half of the address. Since you have already understood that there are thousands of points on this Earth surface which are the same latitude. Remember, those who are not getting it, if I open my hands to show the diagram, what is this point? C. This is A. This is P. If I say this is the latitude of P. Now, if I rotate my right hand like this, wherever this fingertip is going, it is representing all the points which are the same. See here, this also is same latitude, no? If I keep it stationary, I move my right hand like this. So all these points are what? They have the same latitude, that of P. So I can't reach to P with just this information of latitude. So I need one more angle, that is called longitude. So to reach to P, we need to see how many degrees this P is on the east or west of the reference line which our ancestors chose in that conference of 1884. And you know the reference line was the line which is passing through the place called Greenwich, and it is joining North Pole with South Pole. Means we chose Greenwich meridian as our 0 degree meridian or prime meridian. Now, since I'm doing this lecture in India and we are in the Eastern Hemisphere, so what I do is I keep P on the east of Greenwich meridian. And for this, I take this point as the place called Greenwich, which is little east of London. It's a small town, little east of London. So what is this line now? The line which joins North Pole with South Pole here and is passing through the place called Greenwich. This would be called as Greenwich meridian. The other name is 0 degree meridian, or it is also called prime meridian. So please mark the way I have done it on the board, the place called Greenwich. Now, so from this line, we measure how many degrees a place is on the east or how many degrees a place is on the west. Now, before we show this angle, if Greenwich is your reference place, can I say all places which lie on this line have no angular distance east or west from Greenwich. Means all places which lie on this line, they also have 0-degree longitude. Am I right? So a line which joins places of the same longitude would be called as meridian. That is the reason that we are calling it as 0-degree meridian or prime meridian. Now, whatever is the longitude of P, can I say it would be the same longitude for all the places here? So now ask yourself, what is the angular separation between this line, which is our reference line, and the line which is passing through P? Now, in a crude way, can I say, if my right hand represents the Greenwich meridian, then if I keep my left hand over it, at this moment, there is no distance of left hand from the right hand. But to show the diagram, can I say it is something like this? Yes, please. Let's say on my right hand is the Greenwich and on my left hand is the place called P. So what is the angular separation between the two? This angle. And can I say this angle is being represented in the diagram by angle BCA? Means if I join B and C, I'll get the separation. Please do that and check it for yourself. Join B and C. So I repeat, the angular separation between 0-degree meridian and the meridian on which P lies is this angle. Is it okay for everyone? Let us say it is y degrees. And on which side we have chosen it? On the east or west? We have chosen it on the east. So this is y degrees east. So what is the longitude of P? It is y degrees east. And confirm this understanding. Can I say you can reach the point P on the Earth's surface if you move x degrees north of the equator and at the same time you move y degrees on the east of Greenwich meridian. If you move these two distances together, you'll reach the precise point location, that is P. Now, let's see roughly again, what is the maximum variation of longitude? If my right hand is the reference meridian, the Greenwich meridian, I can move from here on the east maximum 180 degrees east, and I can move the same on the other side, and that would be 180 degrees west. So it means longitude would vary from 0-degree to 180 degrees east, or it would vary from 0 to 180 degrees west. And class understands that 180 degrees east and west coincide. Yes, please? And very soon, after 1.5 lectures, it will become, what is this line? It is going to become international date line. When I'll deal with the concept of time, this will become a fascinating line across which we'll have a change of a day on the calendar. So I believe that class has understood longitude and the concept called meridian. Now, we said parallel is called parallel because lines of latitude run parallel to each other. So a student may ask me a question that, sir, what is the significance of the term meridian? And if you look at the UPSC question papers, you'll find this term has been asked in many public exams in India, that what does this word meridian indicate? Now, I speak on this. First, you write the definition of longitude and meridian. So please write longitude and under that write 3 or 4 points. Longitude is the angular distance. Longitude is the angular distance between the meridian passing through a given point, given point is P in our case. Longitude is the angular distance between the meridian passing through a given point and the Greenwich meridian, Greenwich meridian, and the Greenwich meridian. Please don't look into each other's notebook. Confidence is a key. I am going to repeat the notes So if you're not able to write it in the first go, wait for me to repeat. No, those who look into the other's notebook throughout the course, they will keep doing this only. I tell you, this is a personality trait which will develop naturally. That even if you are writing correct, then you. So have you develop your personality also. No, have confidence that teacher is going to repeat. Do I repeat the notes or not? I'll do that 10 times. I'll repeat if you wish. Okay. So please write. I repeat. Longitude is the angular distance between the meridian passing through a given point and the Greenwich meridian. Further write the same point. It is measured east or west. It is measured east or west of the Greenwich meridian. Greenwich meridian. It is measured east or west of the Greenwich meridian. Next point. Longitude varies. Longitude varies 0 to 180 degrees. Longitude varies 0 degree to 180 degrees east or west. The right, next point, meridian. Meridian is a line joining. Meridian is a line joining places of the same longitude. Meridian is a line joining places of the same longitude. Now let's go for understanding what is the significance of the term meridian. Now see, the term meridian relates to the concept of time. I could postpone this discussion for meridian to my next lecture when I'll discuss time. But since I'm using the term today, so I must tell you in brief what is the significance of the term meridian. Now see, in the coming class, I would be teaching the concept of time. Under time, we have two sub-concepts, local time and what is called standard time. Now, what is local time? As the term indicates, if I fix my watch for a place like Karol Bagh in relation to position of the sun in the sky, then that time would be called as local time. So local time of a place is the time which is fixed in relation to position of the sun in the sky. Now you may have a reaction immediately that sir, we don't fix our watches to the sun's position. We don't fix watches to the sun's position these days because we are often using standard time. For most of the things in life today, humanity is using standard time. Only for some religious rituals we use local time. For example, you may need this time in the month of April next year. Next to next year. I hope you are getting not understood. Some people have understood that next year, whenever you will take the exam, 2024, 1 month before the exam, you will understand that classes have done nothing great. And you also have not done anything great in the room. And you now need divine intervention. So you go to a priest in this area and tell the story that I paid huge amount of fee. I have spent a lot in Delhi for food and other such things, but I have not reached anywhere. The priest will say, you should have come to me earlier. So the priest will say for next 7 days, visit me. Together we'll make certain religious rituals. And that would perhaps help you in the examination. And rituals are performed generally at local time of the place. So the priest will say, set your watch as per the time of Karol Bagh. And for next 7 days, visit at this time and we'll do together seek divine intervention. Okay. So how would you fix your watch if you need it for that particular purpose? You have done it in school science. I can fix my watch with the sun's position in the sky by identifying the position or time called 12 noon. What is 12 noon local time? 12 noon local time is the time when the sun reaches. When sun reaches. Now many of you are saying overhead. Yes, it is given in books as overhead, But I would suggest you today in the some other part of the lecture that better than overhead is the term or the point sun reaching the highest in the sky. Those school books write overhead, but a little later you realize that sun cannot be overhead at all the places of the earth. Sun can be overhead only in one small area of the earth. But every place has 12 noon local time. So what is the best definition of local time 12 noon? When the sun reaches highest in the sky. It may not be overhead position, but it is highest for the place. So 12 noon local time is the time when the sun reaches highest. Now, how would I know that sun in my area has reached highest? You have done it in school science, that if I keep an object on the road outside and wait for that moment when the shadow casted by that object is the shortest, that will tell me that sun's rays are coming at maximum inclination. It means sun has reached highest. So by looking at the position or the time, the moment when the shadow given by the object is the shortest, I can identify 12 noon. So this is how we fix our local time. Now let's go into history. You all have heard about Greeks. The Greeks were pioneers in many fields of knowledge. But many of you also have heard of the Roman Empire in Europe. Now, Romans and Greeks had one very clear difference. Greeks were more intellectually oriented people. They were into pure sciences. And Romans in Europe were more practical people. They were not concerned with the basic questions of nature and life. They were more into making their empire as large as possible. And they did succeed in that. Roman Empire became the largest empire of their time. So it means basically I'm saying Romans were very practical people. They were more into administration. They were more into business. And you know, those who are practical people, they give importance to the concept of time. So Romans were great experts in the concept of time. And Romans throughout their empire had constructed what we call as sundial. Almost every one of you would have gone to Jantar Mantars in India. And in Jantar Mantar, we have a concrete structure which is called sundial. And with the help of that sundial, we can locate, we can find out the local time of a place. So Romans were great experts in the construction of those sundials. So Romans gave us the basic concept of local time. And now mind this, in telling time, Romans gave primacy to this 12 noon. Means it was the Roman Empire which gave the importance, the prime importance to this moment of the day. And to indicate 12 noon moment, these Romans use the word meridian. Meridian has come from two Latin words, two Latin roots. Meri in Latin means sun's highest position. We'll write it later, just follow me in the board. And dian comes from the term dime. Dime in Latin means a day. So what is meridian? The moment of the day when the sun is highest in the sky. So meridian is a term relating to the concept of time. And it indicates which moment of the day? 12 noon moment when the sun is highest in the sky. And this is what humanity is using even today. You are using today AM and PM. AM is anti-meridian, means before 12 noon. And the second is post-meridian, PM. So it means the system we are using worldwide today was devised by Roman Empire. Now, you still might have a question that they have concept, the meridian term related to time, but why we are using the term for a line? Yes or no? So why are we calling this, like, let's say my left hand is the earth, the globe, this is North Pole and this is South Pole. So it is meridian, a line connecting North Pole with South Pole. Now, why are we calling this line as meridian? Because in the concept of time, I'll teach you, all places which lie on a given meridian, they have the same relationship with the sun. It means all places which lie on the same meridian would have same local time. So since this line also relates to the concept of time, that all places have the same local time, so therefore they call this line as meridian. Okay. More on this in the chapter of time. You just write on the margin. The word meridian indicates, or write the title meridian and write a sentence, please write. Romans use the word meridian. Romans use the term meridian or word meridian to indicate 12 noon moment of the day. To indicate 12 noon moment of the day. That is the moment of the day when the sun is highest in the sky. Moment of the day when the sun is highest in the sky. I repeat, Romans use the term meridian to indicate 12 noon moment of the day. That is the moment of the day when the sun is highest in the sky. Moment of the day when the sun is highest in the sky. Now, Bharti says, repeat, I said, the term meridian was given by Romans to indicate 12 noon moment of the day, and it is the moment of the day when the sun is highest in the sky. Now, just confirm this understanding. Can I assume that class has understood latitude, angle, longitude, and the line called parallel and meridian? Okay. And the network of these lines is what we call as the grid system. Okay. Now, this is one part of the lecture. Now, let me show you what is the next part. In a way, we can say we have learned two ways to move on the Earth's surface. We can move on the Earth's surface latitudinally, means we can move north and south, and the other is we can move longitudinally, means east and west. Now, let me suggest you that longitude would be more often discussed in relation to the concept of time. For example, let me show you some trailer of what will come in the lecture on time. Did I say anything on the? Very good. So there's a globe in my left hand. Now, I would say when I'll start teaching time, I'll say Earth spins once in 24 hours. When I say Earth spins once, it means it covers 360 degrees of longitude. So it means I would equate 360 degrees of longitude to how much time? 24 hours. When I'll simplify this relationship, I will get to have 1 degree of longitude would mean a time difference of 4 minutes. It means two places which are separated by 1 degree of longitude, they would have a time difference of 4 minutes. But when you have a difference of time, there are two possibilities, or one of the two possibilities, that a place is ahead of the other or a place is behind. So then I'll bring the idea of direction also. I will say Earth rotates west to east. So any place which is on the east would see the sunrise earlier. For example, Japanese, Australians, New Zealanders, they would face the sun earlier than we Indians. So it means they are ahead of us. And we Indians are on the east of Americans. And at least in this field, we are confident that we are ahead of Americans. Yes or no? And Americans cannot do anything now, because the Earth rotates west to east. So it means two learnings. 1 degree of longitudinal difference would mean difference of 4 minutes. East you are ahead and west you are behind. So the whole lecture of time would be primarily based on longitude. I'm not saying that time would have no connection with latitude. It does have, but that will come at a secondary level. Primary relationship is with longitude. Now, let us see what is the significance of latitude for our course. Very soon, in the next section of the lecture, you will understand that which are the important parallels of the Earth. Means I am going to identify important parallels of the Earth. And if I cash on your knowledge of school days, you have heard of two important parallels called tropics of Cancer and Capricorn. Okay. That there is a, if this is, remember, parallels are circles on the globe, but on the board they would become lines. So this line represents equator. So then there is a parallel called Tropic of Cancer, which is at an angle of 20.5 degrees north. And there's a mirror image of it on the other side. So this is 20.5 degrees north parallel. And this is 20.5 degrees south. Now, after 5-10 minutes, I'll discuss and tell you the reason also. At this moment, you just remember that as Earth goes around the sun, because of some change of relationship, mind this, as Earth goes around the sun in 1 year's time, the relationship between the Earth and the sun will keep changing. And you know, when relationships change, something happens. I'm talking about the relationship of Earth and sun. When the relationship of Earth and sun would change, the consequence is seasonality of the Earth. So if I was to sum up in one sentence the lecture of seasonality, which I have to take later, I would say seasonality is a consequence of changing relationship of Earth and sun. And in that lecture, we'll understand that as Earth goes around the sun in 1 year's time, though the sun doesn't move, but because of the changing relationship of Earth and sun, it appears as if sun is also moving. It means I'll show you briefly today that as Earth goes around the sun, there is an apparent movement of the sun. And what is that movement? That as we go towards the, means think of, let's say, as when we are in summer season, summer of northern hemisphere. During summer of northern hemisphere, sun would appear to move towards the north. And on 21st June approximately, sun would reach the farthest position of the northern hemisphere, and that farthest is 20.5 degrees. And this parallel, which is at 20.5 degrees, which is representing the farthest position of the sun or sun's apparent movement, this would be called as Tropic of Cancer. Now, Cancer is like your name or my name. That is, Cancer relates to the zodiac sign of the times when this system was being devised. So there's nothing technical for me to explain about Cancer or Capricorn. What is technical is the word tropic. We will write very soon that word tropic comes from the Latin word tropicus. Tropicus in Latin means a turn. It means this is that parallel of the Earth from where sun appears to take a turn. It means during summer of northern hemisphere, sun would appear to move towards the north, and on 21st June approximately, it would reach the farthest position of the northern hemisphere, and from here it would appear to take a turn and it will move towards the south. And when we Indians have winter in northern hemisphere and Australians are summer, the sun would appear to move towards the south of the equator. And on approximately 21st or 22nd December, sun would reach the farthest position of the southern hemisphere, and that is Tropic of Capricorn. It means what you need to understand at this moment is that the two tropics represent the farthest limits of the apparent movement of the sun. It means this is the only area of the world where sun can be overhead. In this area beyond the Tropic of Cancer and this area beyond the Tropic of Capricorn, sun will never be overhead. Is this understood? Because in 1 year's time, the sun is moving in this area. Clear? Yes, please. So now, let me show you a picture which will confirm you for today's lecture, because later it would be done in more details, that what do I mean by changing relationship of Earth and sun. Okay, let me show you something from the handout which I have to use in a very interesting topic to be done later with you. I'll be doing a topic called reasons for seasons. Okay, means we'll see what causes seasonality of the Earth. Remember, this topic would come later in our classes. You just today focus on this sketch. As Earth goes around the sun, do you notice relationship of Earth and sun is changing? Those who are not getting my point, first understand the concept called axis of the Earth. What is axis? It is my question. You just be a listener, right? Means I'm trying, see, I have to take 3 classes a day. 7.5 hours of standing and speaking sense. So I have to keep motivating every moment. What is axis? Axis means imaginary line joining North Pole with South Pole, passing through the center of the earth. So see, this black line is representing axis. Now, let us say this is the Earth's axis. The moment I'll say in any lecture, this is axis of the earth, you will visualize a globe around it. Only then this will become axis. So let's see what is the relationship of Earth and Sun on 21st December. And before that, let me give you some orientation for the future classes. As Earth goes around the Sun in 1 year's time, the relationship of Earth and Sun will keep changing. There are 5 reasons for, remember I have given the title reasons for seasons. We'll discuss certain 5 reasons, but I'll not disclose that today. There are 5 reasons which are responsible for changing the relationship of Earth and Sun. Now, as Earth goes around the Sun in 1 year's time, every day relationship will keep changing. But daily changes are very small. We'll not be able to notice or will not be able to comprehend those changes easily. So our scientists will make us understand changing relationship of Earth and Sun on 4 important days of the year. And to make my lecture interesting, I'll say those are 4 anniversary dates of Mother Nature. So I'll show Earth and Sun relationship on how many days? 4 days, which will be called as anniversary days, which are the anniversary dates. And what are those? You have done it in school. 2 are called as solstices and 2 are called equinoxes. Now, what is solstice? See here, solstice would mean that Sun has reached farthest in the given hemisphere. So when on 21st June, Sun reaches 20.5 degrees north, that is the farthest position in the north hemisphere. For we Indians, it would be summer solstice, right? And for Australians, the same day would be winter solstice, because you know, as I move from one hemisphere to the other, season will get reversed. And when on 21st December, Sun is overhead on the Tropic of Capricorn, for we Indians, it would be winter solstice, and for Australians, it would be summer solstice. So solstice would be the 2 days of the year when Sun has reached farthest in the given hemisphere. That north hemisphere and southern hemisphere. And then there will be 2 days called equinoxes. What are the 2 days called equinoxes? You will see on 20th March and on 22nd September approximately, Sun would be overhead at equator. Okay, let me show you briefly that today. Take this pen as the axis of the earth. And my left hand is the Sun. So on 21st December, this is going to be the relationship of Earth and Sun. Keep your eyes on the hands and I say something, you confirm this. I say in December, southern hemisphere is leaning towards the Sun. Yes, please, yes or no? And so Australians will have summer and our hemisphere is leaning away. So we have winter. And on 21st December, Earth and Sun are so placed that Sun appears to be over the Tropic of Capricorn. That is the farthest position of the Sun. Now, this is winter solstice for we Indians and summer solstice for Australians. Now, as Earth goes for the journey, in the next 3 months, as Earth covers 1/4 of the orbit, remember every day the Earth's relationship will keep changing, but we'll see the change after 3 months. After 3 months, if I am the Sun and this is the Earth, Earth and Sun would be so placed. Do you notice a big change? Here, North Hemisphere was leaning away, Southern Hemisphere was leaning towards the Sun. But on 20th March, after 3 months, the Earth and Sun are so placed that none of the 2 hemispheres is leaning towards or away. And where does the Sun appears to be overhead? Right over the equator. So it means here the Sun was overhead at Tropic of Capricorn. And in the next 3 months, what happened? Sun gradually appeared to move towards the north. And on 20th March, it reached equator. Remember, in reality, Sun is not moving. It is all because of changing orientation, the changing relationship of Earth with Sun. And as Earth goes for the next quarter of the journey, on 21st June, Earth and Sun would be so placed. My right hand is the Sun, and the left hand represents the axis of the Earth or the globe here. Now, which hemisphere is towards the Sun? Northern hemisphere. We have summer and Australians have winter. And where is the Sun overhead? Tropic of Cancer, right? And in the next 3 months, the relationship would be such, which is similar to what it was in March. So March 20th and September 22nd would be equinoxes. What is equi? Equi means equal, nox means night. It means 20th March and 22nd September would be those 2 days of the year when all the places of the earth would have equal length of the day and night. Okay, how and why, that will be we'll understand very soon. But at this moment, you just confirm this understanding that in 1 year's time, Sun appears to move between the two tropics. And please check, this is visible here. See which hemisphere is towards the Sun on December 21st? Southern hemisphere. Sun appears to be overhead at Tropic of Capricorn, right? We have winter and Australians have summer. After 3 months, the Sun would appear to be over the equator. After another 3 months, Northern hemisphere is leaning towards the Sun and Sun appears over the Tropic of Cancer, and in September again over the equator. Let's see it better. Let's see in a better sketch. June 21st. Where is the Sun overhead? Tropic of Cancer. Okay. December 21st. Where is the Sun overhead? Tropic of Capricorn. This is the relationship on 20th March and, yes please, 22nd September. Okay. So all this would be understood in all technical details later. You just tell me, is that okay for today's lecture, that you have understood that as a relationship of Earth and Sun changes, the Sun appears to move between the two tropics in 1 year's time, right? Is that fine for everyone? And if Sun appears to move between the two tropics, can I say these two tropics represent the farthest limits of the vertical rays of the Sun? Yes, please. Means Sun cannot be beyond these two lines ever vertical. It means in the rest of the world, the Sun is going to be always at an angle. Means it will give us the rays of light at angles less than 90 degrees. Okay. So just wait. I have seen your hand. Just wait. Okay. You ask me. Everywhere the axis remains tilted. Okay. That you'll understand in the lecture on seasonality. Earth's axis will remain tilted always. And that tilt is 20.5 degrees. Right? But that you'll understand the chapter of seasonality. Please understand the problem for the person who is on the platform. Everything cannot be taught in 1 day, no? 15 years of no learning. How can it be completed in 1 day's lecture? That's why we are going into the discussions in parts, okay? You just understand, at least we have seen this, that as Earth goes around the Sun, relationship of Earth and Sun is changing, yes or no? How, why, and all that, we are here for a number of meetings, no? Then only you'll understand that. Remember, everything takes time in life. So learning will take some time. So this relationship change is important. Details would come as we go further. Now, be on the board for a while. Think of latitude. Longitude primarily relates to the concept of time. And listen to the next 5 minutes carefully, because I'm going for a very broad generalizations, which would be of great help in ecology and geography. If you have understood that Sun in 1 year's time moves between the two tropics, can I say the primary distribution of sun's light on the Earth's surface, I repeat my words, the primary distribution of sun's light on the Earth's surface would be governed in terms of latitudes. Did I give you a term insolation last time? Okay, write on the margin a term insolation first. Please write on the margin this term. What is insolation? Please see here. This term is an abbreviation of 3 words. It stands for incoming solar radiation. So write this. Insolation stands for incoming solar radiation. Incoming solar radiation. It means whatever energy of the sun reaches the Earth, it is called as insolation. Now, I make certain statement. You please confirm that you agree with that. I say the primary distribution of insolation would be seen in terms of latitudes. Those who are not getting the point, if sun moves between the 2 tropics, can I say it's clear that as I move from equator to the poles, the insolation will keep decreasing? Remember, in lower latitudes between the 2 tropics, the sun's rays will come at higher angles. And beyond the tropics, the rays will come more inclined. And do remember, if this is the sun, when the rays come at 90 degrees or at higher angle, the thickness of the atmosphere being crossed is less. Losses would be less on the way. And second, a given amount of energy would fall in a small area of the Earth's surface. But if the light comes inclined like this at lower angle, what would happen? The thickness of the atmosphere being crossed would increase. Losses of energy would be more. And a given amount of energy would fall over a larger area of the Earth's surface. So is it understood that higher angled sun's rays would lead to more intense heating? Yes, please. And the inclined rays of the sun will lead to more diffuse heating. So what is the broad understanding when you get to know sun is moving in this area of the world? Can I say it gives me a clear rule that the primary distribution of insolation on the Earth's surface is in terms of latitude. And the rule will be that insolation decreases as we go towards the poles. I'm not saying that we are not going to have any difference of insolation in east-west frame. Remember, because of physical features, you may have difference of insolation even in east-west locations. But my submission is, if someone is asking you, how does the insolation vary primarily on the Earth's surface? Would you choose latitude or longitude? Latitude, is it okay? So class agrees that insolation varies on the Earth's surface primarily in terms of latitude. Okay. Now, in the coming days, we'll be talking about moisture content in the air. You know, air holds moisture in it. And we'll see in the coming days that air holds moisture in its intermolecular space. And warmer air has more space. It means moisture holding capacity of air depends on its temperature. And which air holds more moisture? Warmer air. So I repeat my point, that moisture holding capacity of air is a function of its temperature, and the rule of the game is warmer air holds more moisture. So now see what happens. Can I say insolation varies primarily on the Earth's surface in terms of latitude? So as a result, the moisture in the atmosphere also varies primarily in terms of latitude. Remember again, longitudinally differences are there, but I am discussing which variation? Primary variation. Okay. So there is a primary distribution of insolation in terms of latitude. There is a primary distribution of moisture in the atmosphere in terms of latitude. Now, can I say the heat of the sun and the moisture of the atmosphere, these both are major elements to decide the climates of the world? Means the moment someone tells you the word climate, which elements of the nature come first to your mind? heat and moisture. Heat in terms of temperature and moisture in terms of the occurrence of rain or non-occurrence of the rain precipitation. Yes or no? Even a common person on the road, if I ask that what do you understand by climate, he or she will tell me something which relates to heat and moisture. So if class agrees that heat and moisture vary primarily in terms of latitude on the earth's surface, can I say the major climates of the world would vary in terms of latitude? It means when I'll move from equator to the poles, there would be a variation in the climates of the world. And can I say climates of the world will decide the vegetation, that whether I'm going to get a desert or a forest or a grassland, or what type of a grassland, what type of a forest. So can I conclude that vegetation types of the world would vary primarily in terms of latitude? And you know, the moment I say climate and vegetation vary primarily in terms of latitude, it means life on the earth's surface varies primarily in terms of latitude. It means most of the things we have to study in nature, in the subject of geography and ecology, they are going to vary primarily in terms of latitude. Okay. So since we have to prepare ourselves for future classes of ecology and geography, so it means what is advised today is that we must divide our Earth's surface from equator to the poles in terms of latitudinal regions. If tomorrow in some lecture, me or some other teacher has to talk about one area of the world, don't think we should have some terminology for it? At the moment I mention that term, you must get a picture of this area, right? So it means what we are going to do in this section of the lecture is, we'll identify the important parallels of the earth. And then on the basis of those important parallels, we'll divide the whole earth surface from equator to the poles. Clear? Now, before I do that, let me show you the, now see, the way I have discussed this sketch, would it be fine if I say, first important parallel is equator? Yes, what is the most important parallel of the earth? Equator. And besides equator, we have understood Tropic of Cancer and Tropic of Capricorn are also the important parallels. Clear? Let's bring the importance of Arctic and Antarctic circles. Have you heard of it? So see, first let me show it through the pen, and then I'll do it in the diagram here. This is a relationship on which day? December 21st. On 20, I'll make a statement, just visualize this in mind. I say on 21st December, sun is overhead at Tropic of Capricorn. Is it okay? Now listen to this statement and tell me, is this understood? On 21st December, the farthest reach of the sunlight in Northern Hemisphere is up to 66.5 degrees north. Look at my right hand. Where is the farthest reach in the Northern Hemisphere? Up to this line. And what is this? 66.5 degrees north. And this is what science calls as Arctic Circle. Okay. And what is going to happen in the next 3 months journey? As Earth goes from December to March, on 20th March, light of the sun will go like this. It will touch North Pole as well as South Pole. It means what has happened in the 3 months from December to March. In the 3 months from December to March, this area from 66.5 to 90 degrees north has gradually come under the sun's light. Yes or no? So it means on 21st December, farthest reach of the light was up to 66.5 degrees. And gradually, as Earth went for the next 3 months journey, the higher latitudes beyond 66.5 came under sunlight. And finally, on 20th March, even the North Pole received the light. And what is the position on 21st June? This is the relationship. So where is the sun overhead on 21st June? Tropic of Cancer. I make a statement, please confirm this understanding. I say on 21st June, the farthest reach of the light in Southern Hemisphere is up to 66.5 degrees south. And that is what science calls as Antarctic Circle. Remember, circle is the term circle indicates that these are parallels, which are circles, and Arctic and Antarctic are just names. Now, let's see it through this sketch. June 21st. June 21st, where is the sun overhead? At Tropic of Cancer. But what is the farthest reach of the light in the southern hemisphere? It is up to this line. It means this area of the earth would not see the sun for 24 hours on which day? On June 21st. Is this clear? So just confirm this understanding once again. I repeat that on 21st June, sun is over at a Tropic of Cancer, and the farthest reach of the sunlight in the southern hemisphere is up to 66.5. Okay. And please confirm the opposite here. On 21st December, the overhead position is Tropic of Capricorn, and farthest reach of the light is up to Arctic Circle. Clear? And on equinoxes, you find sunlight is reaching North Pole as well as South Pole. It means I am the sun, this is the earth. And light goes like this. Okay. So, with all this discussion, can I conclude that equator is the most important parallel? Then tropics are important, and then Arctic and Antarctic circles are important. Now, someone may ask me a question, sir, why are they important? I say, as per my discussion, these are the parallels which help us understanding the distribution of insolation on the Earth's surface. Yes, please. And you have just been told within in a very simplified way that insolation decides almost all the important things we have to study in nature, both in the subjects of geography as well as ecology. So, write the title. And there are some students online, they are worried about where would these handouts be given to them or not. See, no, it's for my personal consumption. See, everything would be given. Please focus on what is being taught. All these handouts will come when I'll deal with the chapters like, right, seasonality, etc. Okay. And there is a student who is worried about how the time will be defined at the poles. Am I teaching time today? No. So please don't go ahead of the teacher. No. Who is a good student in life? Who is always one step behind the teacher? Okay. I tell you, Miss, who is a student? Who is to learn? No. And when would you learn? When you are behind the teacher. If you are jumping ahead of me, I can't do anything. Okay. So please I understand your curiosity that you want to know everything today. But I asked my students, where was this curiosity for the last 15 years? Okay. So please just be in the process of learning. You know, it takes time. So please write the title, Important Parallels. And please show them with a sketch the way I do it on the board. And I draw in the center the first important parallel, 0 degree. And keep writing on the line the name. This is equator. Now, what is the next important parallel? Tropic of Cancer. 23.5 degrees north. Now, there may be a question in someone's mind that why sun cannot go beyond this, because this relates to the tilt of the Earth's axis, right? Which I'll be teaching the topic of seasonality. And what is this parallel called? Tropic of Cancer. And the mirror image in the southern hemisphere would be 20.5 degrees south. This is called Tropic of Capricorn. The next important parallel is Arctic Circle here, 66.5. Circle for the reason that these parallels are circles on the globe. The opposite hemisphere, it would be called as Antarctic, 66.5 degrees south. Antarctic Circle. And finally, you have the poles, the North Pole and the South Pole. Now, having drawn this, please write 1 or 2 sentences, then I'll take you further. Please write. Okay, complete this fast. Please write the term tropic comes from the Latin word tropicus. The term tropic comes from the Latin word tropicus, which means a turn. Which means a turn. And it refers to the parallel, and the term tropic refers to the parallel, and it refers to the parallel from where the sun appears to take a turn. I repeat, the term tropic comes from the Latin word tropicus, which means a turn, and tropic refers to the parallel from where the sun appears to take a turn. From where the sun appears to take a turn. Then right, next point. The two tropics represent the farthest limits of the apparent movement of the sun. The two tropics represent the farthest limits of the apparent movement of the sun. The two tropics represent the farthest limits of the apparent movement of the sun. Now write a similar sentence. The third point, next point, please write. The two tropics represent, again write the same. The two tropics represent the farthest limits of the vertical rays of the sun. The two tropics represent the farthest limits of the vertical rays of the sun. The two tropics represent the farthest limits of the vertical rays of the sun. Yes, please. Is that all understood? Now, why are they important to us? Please write one more sentence, one more point. Please write. The parallels shown in this diagram are important. The parallels shown in this diagram are important. The parallels shown in this diagram are important as they help us understanding the distribution of insolation on the Earth's surface. As they help us understanding the distribution of insolation on the Earth's surface. The distribution of insolation on the Earth's surface. Now, if you have understood that major elements of nature are primarily distributed in terms of latitude, it means for most of our geography and ecology classes, we need to move from equator to the poles. Since we are trying to make foundations for our future classes, so what we do today is that we divide our Earth surface into 6 sub-regions from equator to the poles. So that in future, for any subject like ecology or geography, where we are dealing with the physical reality of nature, we should have one particular terminology for a particular area, which should mean almost the same for everyone in the class. Yes or no? So we are going to divide the Earth surface from equator to the poles into 6 latitudinal regions. Okay. So write this title: latitudinal regions. Now, I can use the word region. Some book may use the term zones, or some other book may use the term belts. All these are 3 popular terms: latitudinal regions, or belts, or zones. There's this student Anchal asked you to repeat the meaning of the term tropicus. Tropicus means turn. It means tropic is a parallel from where the sun appears to take a turn. And someone is asking what was the title of this discussion. I said important parallels of the earth. And now is the latitudinal regions or zones. And there's a student asking, how is this important for the males? It means, is this important for males? It is important for the exam only. Then important is this, that when you have to have the study of the earth for subjects like ecology and geography, we can't move without these basics. Okay. Now, you understand latitudinal regions would mean that you are going to divide the earth in terms of latitudes. Now, I'll do this division from the equator towards the poles. And how many regions will identify? 6. Now, I start from equator and I say scientists have first identified a region called equatorial region. And do remember, whatever comes in the next 20 minutes time, it is based on scientific observations of nature. It is not based on any discretion of yours or mine. It is based on real nature outside, that scientists found the nature in one particular area, and on that basis they go for such kind of terminologies. Now, what is the first region they have identified? It is called equatorial region. Please keep writing this with me. Equatorial region. How many total regions I said I'll identify? 6. Now listen to the main point first, and then we'll go for marking those 6 regions. See here. In English, when I use the word equatorial, it immediately tells you that teacher is talking about area near equator. Yes or no? That by equatorial I mean some area here near equator. Then when you use the word region in English, by this we mean an area with some homogeneity in it, an area which has a common identity. For example, if your Indian geography book writes that this area of India makes wheat region of India, the moment you get this phrase that this area of India is wheat region of India, it means immediately you understand that this area of India has one common identity in terms of the predominance of the crop being wheat. That here the main crop is wheat. So region in English means an area with some homogeneity, means some common identity. So how do I understand equatorial region? It means the area near equator with some particular identity of its own. Is that yes or no? So mind this now. Equatorial region would mean an area near equator with a particular common identity. Now let's suppose I come to teach you climates of the world. Can I say the day I'm teaching climates, the equatorial region would be seen in terms of climatic homogeneity? Yes, please. And it would have one definition. Means I'll say in terms of climatic homogeneity, the equatorial region means this particular area. Means 0 to some degrees north and 0 to some degrees south. But day after tomorrow, I start teaching agriculture of the world. Don't think in terms of agriculture as a topic, the definition of equatorial region would change. Means now I'll have to say there is another area near equator which has one common identity in terms of agriculture. Because agriculture depends on climate, but it also depends on soils and government policies, etc. So I hope you are getting my point, that each of the 6 regions we are going to describe today would have their definitions in terms of the purpose of our study. If I'm studying climates, each region would have one particular definition. If I'm studying agriculture, the definition would change. If I'm teaching mineral distribution of the world, definition would further change. Is that yes or no? So it means the class needs to get the point that each of the 6 regions I explain on the board today, their definitions will vary as per the purpose of study. That what exactly I'm interested to study today. But since we are in a general studies class, we don't have one particular purpose of these classes. We don't have to only study climate, so we don't have to study only agriculture. Someday we are studying climate, sometimes we'll be studying agriculture, sometimes mineral distribution, sometimes something else as such. So it means what kinds of definition we need to go for? We need to go for general definitions. Means in general, what is the region called? Equatorial. So keeping this general orientation in mind, because we are in a GS class, so we go for all the 6 definitions, the way I'm going to put them. So equatorial region in general would mean 0 degree to 10 degrees north and south. It means background understanding is for one particular purpose, definition may change. Yes or no? For some particular purpose, definition may be 0 to 8 degrees north and south. For some other purpose, it may be 0 to 13 degrees north and south. But in general, for our course, we'll take it as 0 to 10 degrees north and south. So all definitions which will come in this section of the lecture, they will be in general. Okay. So please write this and keep marking the corresponding region in the diagram. So let's say roughly this is that area, which is equatorial region. Now there's a student Shivani asking me something very interesting. She's saying, why did they add half degree, 20th and half? Why didn't they write only 23 to make it easier? Remember, we are in a science class. 20th and half is not based on our discretion. That because of the tilt of the Earth's axis being 20th and half degrees, that is why we have this farthest reach of the sun up to 20th and half, right? So this is not as per our choice, it is as per our nature. So is the first region definition understood? Now let's come to second region. Second region identified by the scientists is called tropical region. Now mind this, generally the term tropical region refers to this whole area between the 2 tropics, Tropic of Cancer to Tropic of Capricorn. So tropical region generally would be taken as 20.5 degrees north to 20.5 degrees south. It means it goes without being said that equatorial region becomes a subset of tropical region. Subset, you understand? You must understand, because CSAT is qualifying. Yes or no? So what is tropical region? This whole region. This region is tropical region. So we have identified 2 regions out of 6. Now let's see the next part. Please don't write till I write on the board. I repeat, a good student is one who is one step behind the teacher. So write something when I have already written on the board. No, let me speak something and then see what I conclude finally. Now, let us think of going into this area. You please don't mark, just be on the board. Think of this area. And similarly, think of this area. You know, sun is moving till the Tropic of Cancer and Tropic of Capricorn. Now, let's say this is the sun and this is Tropic of Cancer. Here in this side, you have equator. So don't think when sun reaches Tropic of Cancer in the month of June, then the area beyond the Tropic of Cancer here will also get some good amount of light. When there's a bulb here, light comes on the other side also. It means you can, by common sense, understand this area of the earth, which is beyond the Tropic of Cancer, would have good amount of heat, and as a result would have physical environment which is quite similar to what we have seen in the tropical region, but it won't be exactly similar. And same way on the southern side, that this area will also get good amount of heat. So this area of the world is seen to be very similar to the tropical region, but not exactly. So what the scientists do is they use a term sub. You know, sub when used as a prefix would mean it is something similar to what follows. So it means scientists have identified the third region as subtropical region. Very good. Sub in English means something similar to, but not exactly. Something similar to what follows. And it is this area. Now you'll ask me, sir, how much area can be called as subtropical? For general orientation, we take a very broad area here and we say 23.5 degrees north to 40 degrees north. And similarly, 20.5 degrees south to 40 degrees south. This area is generally treated as subtropical region. So let us mark this. So this is subtropical region, same way in the southern hemisphere. Now see again the student who instead of focusing on what is being taught, they are going for other questions which are to come in future. There is a student Bhubhuti Bhushan asking me that Earth's axis is inclined with reference to which axis? I'll teach you, I know the answer. Means why are you trying to check my knowledge? Earth's axis is inclined to a plane called ecliptic plane. Okay. So there will be inclination of the Earth's axis seen in relation to ecliptic plane. Let me tell you that something imaginary plane would be defined as ecliptic plane, and we'll draw a perpendicular to that plane, and then we'll see the Earth's axis inclination. Okay, but let it come in this sequence. You just focus on what is being done today. Yes. Louder, please. No, nothing wrong. That's what we have said. 0 to 10 degrees north and south means that only 10 degrees north to 10 degrees south. You are very right. It means teacher is very good. That you understand the things in the very first lecture. So tropical, subtropical is understood. Now we come to fourth region. The fourth region identified by scientists is called temperate region. Now the term temperate is generally used for this whole area of the earth, from Tropic of Cancer to Arctic Circle, and similarly from Tropic of Capricorn to Antarctic Circle. So 20.5 degrees north to 66.5 degrees north. 20.5 degrees south to 66.5 degrees south. And I can mark this area. It means it goes without being said that subtropical region becomes a subset of temperate region. This whole area of the earth is generally called as temperate region. How many subregions have already been identified? 4. 2 are left, right? Now for the last two, we need a little special discussion. Be on the board and do not write till I write on the board. See here, now we are left with this area of the earth. Can I say, based on your common awareness, this area of the earth is an extreme area? By extreme, I mean, in terms of climatic conditions, it is very cold area of the world. And for this reason that it's an extreme area means it's a sort of negative area for mankind. And for this reason of extreme climatic conditions, too cold conditions here, we generally do not have much reasons to visit this area. Yes, please. Means given a choice for world tour, would you first go there? Having seen the entire world, you may say, let me now check polar areas also. No. After 15 years of travel, you may say, I have not seen the polar region. Let me see that also. Okay. But given a choice for first time for a tour, you will not go there. So it means I want to say this area of the earth is a sort of negative area, extreme area. It means we have less reasons to visit this area. And anything which is less frequently visited would be less precisely defined. Which cousin of yours you know better? The close cousin or remote cousin? Close cousin. You are a partner in crime with him or her. No? You know each and everything of that close cousin, and he or she also knows everything. Remote cousin. None of you are interested in each other. No? By societal pressure, you meet at certain occasion, year after years. So this area is less precisely defined because we have less reasons to go there. So for this region, we'll have some broad definition. Will not be so close as we have been here in the four regions. So what I do is, in this area, first I define the term polar region. To make it better understood, I say, first let's identify polar region. Now, what does polar region would mean? I would say polar region would mean area around the poles. Now you will say, sir, how much around the poles? Because you have seen that have been given in four regions we have identified. I have given the definitions in latitudes. So a student will expect me to give definition in terms of latitudes here. But as I told you that this area is less precisely defined. So the best approach for this area would be that we simply write polar region would mean areas around the poles. You ask me, sir, how much around the poles? I will say, let the scholar decide it for the particular purpose he or she goes there. Okay? Means the day we'll go there with one particular purpose, we'll define that in relation to that purpose. But broadly speaking, this area is best understood as, in general, area around the poles. So just mark this area here. And similarly in the southern hemisphere. So we have identified the fifth region as polar region. Now we are left with this area. Please see, be on the board, this area of the world. Now when you go to this area of the world, you find the climatic conditions, the physical environment is more similar to polar region. Means this also is very cold area of the world. So since it is more closer to the polar region in terms of its features, so scientists coin the term subpolar. Means something similar to polar but not exactly. So the sixth region is subpolar region. Now you will say, sir, how would you define this? I've already given a hint. We are going for less precise definitions. We are going for broader definitions. So how do I define it? Just listen to me first. I say these are the higher latitudes beyond or just outside the Arctic Circle and just outside the Antarctic Circle. So write the definition. Sorry. Higher latitudes just outside. Yes, please, just outside the Arctic and Antarctic circles. Now there's a student asking me that is a frigid and polar region the same? I again say, please don't go ahead of the teacher. No, I also know frigid, torrid and all that. Wait, let it come under the right concept, the right way. Okay. So just be a step behind. Now, these are the best definitions of these two areas. But there would be some student who will say, sir, do give me some idea about the latitudes also. Because whenever a teacher doesn't give something, the student believes perhaps he or she is weak here. So after the class, they will explore that area only. So some student will come after the class and say, sir, no, for my idea's sake, tell me the latitudes. So for those students who seek ideas after the class, you can say latitudes of late 60s and 70s are, mind this, latitudes of late 60s and 70s are subpolar region, and latitudes of 80s are polar region. Okay, but I still prefer don't write that. The best definitions are already on the board. Okay, but those who are going to trouble after the class, I'm already giving the answer here though, so that you don't trouble me outside. No, best moment is this moment, right? So late 60s and 70s are subpolar, and latitudes of 80s are polar region. But this is what a good book will write. Now, how many sub-regions we have done on the board? So listen to the next point carefully. Whenever you need a detailed investigation of the physical features of the earth, we go for this scheme. We divide the earth into 6 regions. But in some studies, we may not need this kind of detailed division of the earth. For some discussions, we may need to divide the whole earth in a broader perspective. We may need to divide the earth only into 3 regions. So when you need a broad division of the earth, when you don't need such a kind of detailed division of the earth, so what we can do is, we can think of our earth in 3 broad regions. If you have space on the side of the diagram, you write the way I'm writing. Otherwise, you can note that separately. See here. When you need a broader division of the earth, what you can do is, you can see this part of the earth as tropical region, or think of some other term, lower latitudes. You can think of this as temperate region, middle latitudes, and the whole region will become polar region. Very good. Or higher latitudes. Okay. So whenever we need a broader division, we see earth in 3 parts. I write these 3 parts here. This would be called as, yes please, tropical region. If you don't have this space on this side, you can write separately somewhere. Broader division is 3 regions, tropical region, or we can call them as lower latitudes. So sometimes in some topic, I'll say lower latitudes of the world. And the moment I say, your focus would be on the tropical belt of the earth. And what is this? This is temperate region. Or it would be also referred to as middle latitudes. And this would be referred to as polar region. Or higher latitudes. It means it's something like, sometimes we can think of India as North India and South India, no? But sometimes we have to see the subcultures of North India and subcultures of South India, depending on the purpose of your study. Now there's a student Arindam asking me that, is equatorial region under tropical zone? Yes, I told you. Equatorial region is a subset of tropical region. And we are using, there is a student Prajakta asking me that, can I explain equatorial region again? Equatorial means the area near equator with a particular identity. And generally we defined it as 0 to 10 degrees north and 10 degrees south. Now, are the 6 regions understood? And broad 3 regions, clear? Now, let us now bring a mathematical concept in class. There is a mathematical concept for a sphere which is useful in geography classes, and this concept is great circle. So please write a title, great circle. Now please don't write except the title and be on the board. I'll take 20 minutes to explain the things. Great circle is a concept from mathematics in relation to a sphere. And as I explained the concept of great circle, there would be a secondary concept called small circle also understood for the same sphere. Okay. And I have already made a rule that whenever I use in my lectures the fruit apple, it would always indicate a sphere, though I know it's not, but I will assume it to be a sphere. Now, imagine my left hand is the apple, a sphere, and my right hand is a knife. Knife is a plane and the apple is a sphere. When you run a knife into the apple anywhere to cut it into 2 pieces, I repeat, when you run a knife into the apple anywhere to cut it into 2 pieces, can I say the intersection of the knife and the surface of the apple, the surface of the sphere would make a circle? I repeat, those who are not, please visualize the same again. When you run a knife through the apple anywhere to cut it into 2 pieces, the intersection of the knife, the plane, and the surface of the sphere, the surface of the apple, will give you a circle. Yes or no? Now, if you run the knife through the center of the apple to cut it into 2 exact halves, can I say the intersection of the plane and the surface of the sphere this time would be the largest circle for this sphere? This larger circle will represent the circumference of the sphere. This larger circle, which you get when you run the knife through the center to cut into 2 halves, is what mathematics calls as great circle. So it means great circle is a circle which cuts a sphere into 2 exact halves. And it also represents the circumference of that sphere. Is that okay for everyone? Now, those who have understood, please tell me, for a given sphere, how many great circles are possible?
Infinite.
Some other students, yes, how many? Now, some students are saying 1. These are the ones who never cut their apple of their own. They have been getting it from their parents or someone else. Someone says 2, same person. It means those who say 1, it means they cut the apple into 2 halves like this only. Those who say 2, there is a second method for them. But they don't know, because they have not cut the apple of their own, that you can cut an apple into 2 halves in infinite ways. The only thing you have to ensure is the knife must pass through the center of the apple. So those students who said infinite, that is the correct answer. So for a given sphere, we can have how many great circles? Infinite great circles. Is okay? Now, let us also understand a secondary concept called small circle for a sphere. If you run the knife through the apple anywhere other than the center of the apple to cut the apple into 2 parts, then the circle you will get is called as a small circle. I repeat, when you run the knife through any place other than the center of the apple to cut the apple into 2 parts, then that circle which you get would be called as small circle. Those who are not getting it, get reminded of that day when you had only 1 apple at home and you had to share it with your younger sibling. And you said, since I'm the elder one, so I'll cut it. So you took the apple, you took the knife, and you said, see, we'll have an equal share. See, I'm putting right at the center. And you did that. But the moment you were about to cut, you did this. You lifted the plane, no? So you got a circle called small circle. Fine. So I believe that class has understood the concept of great circle and small circle for a given sphere. This is from mathematics. Now let's bring it to geography. Let's first bring it to today's lecture and then we'll use it for some future class also. Can I say, based on today's lecture, that of all the parallels, equator is the only great circle? Remember this, if my left hand is the globe, this circle, which is the equatorial, which is equator, is the only great circle. All other parallels, like 10 degrees north, or like Tropic of Cancer, or Tropic of Capricorn, or Arctic Circle, they are all what? They are small circles. So it means only one parallel of our globe makes a great circle, right? Now, let's go to the meridians. I make a statement, please think of this. I say, each meridian makes a semi-great circle. Semi means half. Tell me, is this understood? And do remember in the last lecture we have decided, unless until I state otherwise, our earth is spherical in shape, right? So, what does it mean when I say each meridian makes a semi-great circle? When you draw a meridian from North Pole to South Pole, it is half of a great circle. Because if you take one meridian and if you take the counter meridian on the other side, both will make a great circle. For example, 0 degree meridian, if I take on the other side 180 degrees meridian, both will make a complete great circle. So my notes will say each meridian makes semi-great circle. But when you read some school book like NCERT or G.C. Leong's book, for a school child, the author makes it easier by writing that all meridians make great circles. It means school author assumes for every meridian the counter meridian on the other side. So it means if I draw one meridian, precisely it is half of a great circle. But if I take the opposite half, the other side, then both will make great circle. So it means practically I conclude that only one parallel makes a great circle, that is equator. All other parallels are small circles and all meridians make great circles. If I go by school book, or I'll say better statement, each meridian makes semi-great circle. Is it okay? Now this is from today's lecture. When I'll teach you seasonality, remember I said there will be an interesting topic called reasons for seasons. When I'll teach you seasonality, you will get to know that Mother Nature has given us a very good example of great circle. Let's understand what does it mean. As Earth goes around the sun in 1 year's time, at every moment of this journey, sunlight divides the Earth into exact 2 halves. I repeat, as Earth goes around the sun, at every moment of this journey of 1 year, sunlight always divides the Earth into 2 exact halves. One is the light half called the day, and the other is the dark half called the night. So if my left hand is the Earth, and let's say the portion of my left hand towards you is the light half means sunlit hemisphere, and the portion of my left hand towards the board, let's say, is the dark half, means this is day and this is night. Then the edge of the sunlit hemisphere is a great circle. Yes, please? And this great circle is called in science as circle of illumination. So everyone should visualize this, because this concept of circle of illumination would be of great help to understand the whole chapter of seasonality. I'll show you, just wait for a minute. So what is circle of illumination? Nature's example of great circle. I repeat, as Earth goes around the sun, light divides the Earth into 2 exact halves. The light half called the day, the dark half called the night. And the edge of the light half, edge of the sunlit hemisphere, makes a great circle, which is named in science as circle of illumination. Now, it might be little early today, but I'll make a statement. You just try to think on those lines. See here. Seasonality, remember, it is not for today's lecture, but I'm just throwing the idea so that you know What kind of things we'll study in seasonality? Can I say, based on your experience of life of nature, can I say seasonality gets manifested by changing length of a day? Those who don't understand this language, I say, when darkness starts prevailing earlier in the evening, it's an indication that we are approaching winter. Means days are getting shorter, nights are getting longer. So winter is a time when the days are shorter, summer is a time when the days are longer. So one of the manifestations of seasonality for us is variation in the length of day. Now, what would decide the length of a day? The answer would be, length of a day would depend upon how the circle of illumination cuts my earth into two halves. It means the whole chapter of seasonality will be understood if you get to understand that as earth goes around the sun, how the light of the sun cuts the earth into two halves. See here, just to give a rough idea today, but remember this is a part of the future classes, but just to give a future orientation. On 21st December, this was the earth and sun. Yes, please. Now, take my left hand, circle of illumination. Circle of illumination cuts the earth like this. What is the farthest reach in northern hemisphere? Arctic circle. So imagine I'm having a globe in my left hand and knife goes to cut the globe, or you say apple, from the Arctic circle to the center and into two halves. Can I say in this cut, longer proportions of the parallels of southern hemisphere are under sunlight? So Australians will have longer days. Their nights would be shorter. And whatever the northern hemisphere, shorter proportions of the parallels are under sunlight. Our days are short. Nights are longer. Is it okay? This is winter for us. Now, as earth goes around the sun in the next 3 months, relationship will keep changing. And after 3 months, I said for some reasons, earth and sun would be so pleased. Light, the circle of illumination will go and cut the earth like this. Means light will pass through North Pole and South Pole. It means apple on the table, knife going vertically down. When the light will cut the earth through North Pole and South Pole and the center of the earth, can I say each parallel of the earth will get evenly divided? Half length under light and half length under darkness. And that is why all places in the earth would have equal length of the day and night. It would be called as equinox. And how many of you will understand if I say from December to March, the northern hemispheric places, or I repeat, in the from December to March, places of northern hemisphere would have increased in the length of a day. Yes or no? And days would become shorter in southern hemisphere. And after 3 months, this is the relationship of the earth and sun. The longer proportions of the parallels of the northern hemisphere are under sunlight. Our days are longer, nights are shorter. This is summer for us. And Australians would have winter. And in September, relationship is same as March. Okay. So it means I want just a rough idea today. Details will be seen in chapter of seasonality. That in the coming days we'll see circle of illumination is acting like a knife. And this knife is a great circle. So it cuts the earth always into two halves. Okay. Now I'm going to make a statement if it is understood well. Otherwise, leave it for the chapter of seasonality. See here. You all know from your experience, those who cut the apple at home. These others, some may not understand. You can cut an apple with the help of a knife into two halves in n number of ways. Is okay? Same way, what is happening in nature? My earth is being cut by knife called circle of illumination. Always into two halves. But differently at different times of the year. I repeat this statement and I'll do it in two parts so that you have ease in understanding. First, confirm this half sentence. I say half part of this statement. I say circle of illumination being a great circle always cuts the earth into 2 halves. Is that okay for everyone? Second half, I say, but it does so differently at different times of the year. Yes, please. Is this second part understood or not? Some phrases are Greek and Latin. So to make them Indian, I need to repeat. I repeat and take your time to understand, because it's not meant for today's lecture, it's meant for seasonality. So take your time. I'll try to make you understand today itself. I say circle of illumination, being a great circle, will always cut the earth into 2 halves. But it does so differently at different times of the year. It means circle of illumination is cutting the earth differently at different times of the year. Why? Because you know that as earth goes for the journey around the sun, the relationship of earth and sun keeps changing. It means earth is putting itself to the sun's light differently at different times. So the light has to cut the earth at different times in a different way. And that is what gives us changing length of a day. And that is what we understand as seasonality. And to make it better understood and to prepare you for my future classes, let me just show you the cut through that sketch. Now, whatever I show you on the board, if you understand this, it will help you in seasonality chapter as well as some practice which you know about. Have you heard that some countries of the world go for forwarding their watches in the summer season? And this practice is called as daylight saving time, which I'm going to teach you very soon under the concept of time. So, June 21st, earth and sun are placed in a particular way, right? Let's see how the light of the sun cuts the earth, how the circle of illumination runs as a knife. It runs as a knife like this. This is the way the earth is being cut. Now let's see what happens. Equator's half length is under light and half length is under darkness. I make a statement. Let's see how many of you understand. I say equator is the only parallel of the earth which is going to be always get cut evenly throughout the year. Remember, whenever you want to cut the apple into 2 halves, knife has to pass through the center of the apple. So equator remains the only parallel of the earth which is getting cut evenly throughout the year. It means equator is the only parallel where there is no change in the length of a day throughout the year. It means when I said seasonality gets manifested by changing length of a day, this statement is not good for equator. This is good only when I leave the equator and start moving towards the poles. Because equator will always have 12 hours of day and 12 hours of night. Clear? Now, in June, which hemisphere is the summer hemisphere? Northern hemisphere. And southern hemisphere is winter hemisphere. Keep your eyes on the board. First you understand, otherwise I'll show you with the pen. I say, in summer hemisphere, higher you go in latitudes, the day becomes longer. Remember, summer you already know is the time when the day is longer. But we go for a finer point. That higher you go in latitudes in summer hemisphere, day is very long. For example, if you go during summer vacations for the first time for your vacations to a northern European city, you will have a surprise in early sunrise and late sunset. When you sleep in the hotel room in Paris for the first night, very early in the morning, you will be disturbed in your sleep because a lot of sunlight will reach to your room because you didn't put the curtain on the window at night. And you had a very early sunrise and light will disturb your sleep. And late in the evening, another surprise, that watch may be showing 10 p.m. or 9:30 p.m. and the light around you is so much as if it is 4:30 p.m. of Delhi, because the sun is going to set very late. So it means higher the latitudes of the summer hemisphere, you have a very early sunrise and very late sunset. So this is visible. Those who are not getting it, see here. Look at this portion of the parallel and compare it with this. Can I say you get the understanding? Day is longer than the night, but see this proportion. Can I say here the proportion has increased? Night has become shorter further and day has become longer further. See the proportion here. So higher you go in latitudes of the southern hemisphere, days are getting longer. It means these countries would have early sunrise and very late sunset. And this will give them the reason after 2 classes for forwarding their watches for the summer season by usually 1 hour. And this would lead to some conservation of energy for them. And they will call this practice as daylight saving time. But since in our area, remember in India, summer day is longer, but it is not very long as compared to night. Since our day is not very long, so we'll not have a reason to go for DST. Okay. Now, what is DST and all that? Those who don't know, you just leave it. You just understand that this is related to this point being given by the teacher that higher the latitudes, longer is the summer day. Now, keep your eyes on the other side of the equator. In June, southern hemisphere is the winter hemisphere. Yes, please. Now, can I conclude from the diagram, the way the sunlight is cutting the earth, can I say, higher I go in latitudes of the winter hemisphere, the days become shorter and shorter. And nights become longer and longer. See here, this day is shorter than this night. But this day is much shorter than this night. This day is much further shorter. So what is happening in the winter hemisphere? Days are getting shorter as I go higher in latitudes, and nights are getting longer. If you have understood the rules in June, can I say it is opposite in December? And I hope now you understand why this is called equinox. That all parallels are being cut evenly. It means, now confirm this understanding, there are only 2 days of the year in which all the parallels of the earth get evenly divided. Otherwise, equator is the only parallel which is getting cut evenly. But there are 2 occasions, one in March, the other in September, when all parallels of the earth would have half length under light and half length under darkness. And that is why the world will call these days as equinoxes. Okay. So, even if you have not understood everything of it, but tell me, is this statement understood that circle of illumination, being a great circle, always cuts the earth into 2 halves, but it does so differently at different times of the year. And those who understand this statement, you can take it from me that you have understood the seasonality, because this is the crux finally. Okay. Now, let's come back to great circle for one more additional point. The last point is one of the mathematical, my mind this I said, great circle is a mathematical concept. Now I'm going to share with you one mathematical property of great circle which has its application in our life, means in relation to geography and in general life. See, if my left hand is flat like this, if I take 2 points, any 2 points on the flat surface, shortest distance between these 2 points will be perpendicular to the straight line, right? But today we are not talking about flat surfaces, we are talking about spherical surface. We are talking about sphere surface, means curved surface. I repeat the point. The shortest distance between 2 points on the flat surface is the straight line, is the perpendicular distance. Am I right? But if there are 2 points, any 2 points on the surface of a sphere, let's say this point is A and this point is B, and these are the 2 points on the surface of globe or on our earth surface, then mathematically it can be proved that the shortest distance between A and B will always lie along the arc of the great circle joining or passing through these 2 points. It means if my left hand is a globe, if you take any 2 points, I am emphasizing on this point for some reason. If this left hand is a globe, if you take any 2 points on the surface, then mathematically it can be shown that the shortest distance between these 2 points is always along the arc of the great circle passing through these 2 points. When I say great circle, it means that circle which has the plane passing through the center of the globe, center of the sphere. It means I'm saying that this A and B would have shortest route along the, yes please, arc of great circle. It means mathematically we understand the arcs of the great circle give us the shortest routes for the two places, any two places of the earth. You can have the shortest distance by arc of the great circle, and it can be proved mathematically. But since we are in a geography class, we don't need to prove it mathematically. Now, if anyone wants to check it, whether it's correct or not, after the class, take a ball, mark any 2 points of your choice, and take a thread and join A and B, those 2 points, with the help of the thread in different ways. Within a few minutes of exercise, you'll find the shortest thread joining those 2 points will be when the plane of the thread is seen to be passing through the center of the ball. It means when the thread becomes the arc of great circle, then it would be the shortest thread joining those 2 points A and B. Okay. Now, can anyone recall that you have seen this particular point in your school days books? When you read your initial chapters of geography or science book in school, say even 8th or 9th standard, you might recall from the school days geography or science book that when sailors are sailing in the world ocean, they prefer great circle routes. It means to the extent possible, they try to remain as close as possible to the arc joining the two cities they are moving. Means if they are moving from city A to city B, to the extent possible, they will like to remain close to this arc, because that will give them what kind of route? Shortest route. It means the most economical route. Now, I don't know what reason in school books they only mention about sailors, but don't you think common sense and practical reasons tell us the same rule will work in civil aviation industry? And those of you who have gone through international flights from one city of the world to another, you have seen on the screen when they show you the route of the journey, they always show us the big arcs, and those arcs joining the city A and B. Means you're flying from Delhi to Paris or Delhi to, say, London, they will show you the journey through the arc of a great circle, because they are the preferred routes in civil aviation industry also. Or some of you may recall a news item that when we move from Delhi to some European city, many times like Paris, etc., you will find our preferred route is via Pakistan's airspace. Means that is the shortest route. But sometimes Pakistan doesn't allow the aeroplanes of Indian aeroplanes to go through their airspace. And when we have to deviate from that preferred route, our journey time will increase. For example, in general, Delhi-Paris flight may take 8 hours. But when Pakistan is not allowing us, we have to change the route, that it might be 8 hours and say 30 or 40 minutes more. It means we had a deviation from the preferred economical route. So in civil aviation as well as in the world ocean, we prefer which routes? Arcs of the great circle. Okay. Now, let us write all these points. And I know some of you will have a doubt on this last observation. And as you write, if you have a doubt, raise it, or otherwise I'll explain. Okay. So please write. There's a student Ravikant asking me, how did sailors define great circle? Remember, sailors were great in cartography. No, sailors are using different maps and all that. And at higher level, we teach the different kind of map projections, which give us these kind of preferred routes. Okay. So please write note on great circle. First point, any plane, PLANE, that is passed through the center of a sphere. I repeat, any plane that is passed through the center of a sphere, put a comma, bisects that sphere, and creates a great circle, where it intersects where it intersects the surface of the sphere. Where it intersects the surface of the sphere. I repeat, first point, any plane that is passed through the center of a sphere, put a comma, bisects that sphere and creates a great circle where it intersects the surface of the sphere. Now write the second point. A great circle is the largest circle. A great circle is the largest circle that can be drawn to a sphere. A great circle is the largest circle that can be drawn to a sphere, and it represents the circumference of that sphere, and it represents the circumference of that sphere. Next point, for a given sphere, we can have infinite great circles. For a given sphere, we can have infinite great circles. Next point. Of all the parallels, put a comma, equator alone makes a great circle. Of all the parallels, equator alone makes a great circle. In the same point, right? Next sentence. Of all the parallels, put a comma, equator alone makes a great circle. In the same point, next sentence. All other parallels make small circles. All other parallels make small circles. I repeat the whole point. Of all the parallels, equator alone makes a great circle. And then second sentence is, all other parallels make small circles. Next point. Each meridian makes a semi-great circle. Each meridian makes a semi-great circle. Then write the next bullet with the title, Circle of Illumination. Circle of Illumination. Under this you write, sun illuminates one half of the earth. Sun illuminates one half of the earth at any given moment. At any given moment. I repeat, sun illuminates one half of the earth at any given moment. Full stop. Further right, the edge of the sunlit hemisphere, the edge, E-D-G-E, the edge of the sunlit hemisphere put a comma, called the circle of illumination. The edge of the sunlit hemisphere, comma, called the circle of illumination, put a comma again, is a great circle that divides the earth into light half and dark half. Means day and night. That divides the earth into light half and dark half. I repeat, the edge of the sunlit hemisphere, comma, called the circle of illumination, again a comma, is a great circle that divides the earth into light half and dark half. Now you write that property of great circle, that arc of the great circle root. Please write the next point. Arc of the great circle ARC, arc of the great circle, joining any 2 points on the earth surface. Arc of the great circle, joining any 2 points on the earth surface. Joining any 2 points on the earth surface is always the shortest route, between the points. I repeat, you have written arc of the great circle joining any 2 points on the earth surface is always the shortest route between the points. Now, please underline the words any 2 points. Now, please read this sentence again, and there would be some students in the class who would have a problem about this phrase, any 2 points. If anyone has a problem, let me know. Means I want everyone to understand that this feature, mind this on the board, this point, that arc of the great circle is the shortest route. This is a valid statement for any 2 points of the earth surface. Means some students will not understand this point. So please think of what I'm saying now. Otherwise, I'll give a clarification. I'm saying that the statement that arc of the great circle is the shortest route for 2 points. I say this statement is valid for any 2 points of the earth surface. Very good. Miss, I'm saying any 2 points. He has a doubt. Is it possible when a point is this northern hemisphere and southern hemisphere? We will see. Have you not been told meridians are making great circles? Yes. Very good. Equator is a great circle. So certainly arc of the equator would make a great circle. Give me better, like some, this is, yes. Who says that? Or North Pole and South? You already know Earth is perfectly spherical for this topic. What is this? It's a great circle. You should have been asking something better than this. Which are on the same parallel, no?
Not on either.
Very good. I have understood. Now, let's say, see this point. Now, better it is placed by this student. What he says, it's almost the same way here. Sahil is writing, what if both the points are in the are points on the same parallel of latitude? Means if there are 2 points which are on the same parallel, would there be such a rule applicable? I've already said many a times it is possible, it is valid for any 2 points. So let's have a clarification on the board. Just to have a broader, means a complete understanding. So I'll go for 3 cases here. A student may come to me and say that, sir, if there are 2 points on the equator, let's say A and B, you know, on the globe, arc, can I say on the globe, this would be an arc AB. So a student may come to me and say that, sir, since arc AB is the arc of a great circle, because equator is great circle, so it represents the shortest route for A and B. If someone concludes this, I'll say you are 100% correct, right? So I repeat, a student comes to me with one conclusion that, sir, A and B which are lying on the equator and they make arc AB, and arc AB being the arc of a great circle. So arc AB represents shortest route for A and B. I'll say you are 100% correct. Let's have second point. Let us say this is 30 degrees north parallel, or you can think of any other parallel in northern hemisphere. Let's say there's a point C and there is a point D. Now the student will say, sir, arc CD. Remember, even this is an arc. It's a globe, so it's an arc. So a student, the same student will say, sir, arc CD. Since arc CD is the arc of a small circle, So arc CD does not represent the shortest route. Yes, please. I'll agree with him or her that arc CD being the arc of a small circle is not the shortest route, right? I'll agree with this conclusion. But if the student says that for C and D, we cannot have the arc of a great circle, that is wrong. It means I want everyone to visualize in mind that for C and D, we can have the arc of a great circle. Yes, I agree. Arc CD is not the arc of a great circle, but we can join C and D with arc of a great circle, which can represent the shortest route. It means those who are still not getting my point. If you think of C and D as 2 points on the globe or on the apple or on the ball, think of, can you run a knife which passes through C and D as well as center of the apple? Answer is yes. So it means don't say that we cannot have arc of a great circle for C and D. We can have. Yes, arc CD is not that answer, but we can draw an arc which is the arc of great circle passing through C and D. Similarly, if there is 30-degree south parallel or any other parallel, and there is a point E and this point is F. Similarly, student will say arc EF is not the arc of a great circle, so it doesn't represent the shortest route. I'll say yes, you are right. But if the student says that for E and F, the 2 points which are on a parallel other than the equator, we cannot have the arc of the great circle, then that's a wrong conclusion. For E and F, we can have an arc of the great circle. Again, you have to visualize that can I run a knife which passes through E and F as well as center? So it means my summation in the notes is that this statement that arc of the great circle represents the shortest route, it is valid for any 2 points of the earth surface. And those who are still not getting my point, they need to take a ball after the class and then take a knife and mark the points of your choice, and then imagine. Just wait, I'll attend to you. Just wait, let me complete. The arc, you can think of the arc of the great circle by thinking of the knife passing through those 2 points and the center. Okay. Now, let me add something more. Keep your eyes on the board and think of what I add further. Since Earth is spherical in shape, as I go higher in latitude, Earth becomes smaller in size. See here, this Earth is very large, but as I go higher, Earth gets smaller in higher latitude. So I say, and I'll be using it in my coming lectures very soon for proving something very important for air circulations. We'll be using this point that Earth being spherical in shape, Earth gets smaller in higher latitude. Means polar Earth is very small as compared to tropical Earth. Now, keep your eyes on the board and confirm this understanding. Can I say arc of the great circle joining C and D will always lie on the north of this parallel, and the arc of the great circle joining E and F will always lie on the south of this parallel? Because remember, when you join C and D from the north, that will give you the shortest route, and when you join it from the south here, it would give you the shortest route. Is this yes or no? And those who are still not with me, the only way out is that take a ball, mark the points, and then take a knife, and then don't cut the ball, but imagine that can you cut the ball the way I have given you? Okay. Yes. Infinite meridians. I've understood your question. North Pole at this point. Can I draw a meridian or not? How many meridians we can draw? Infinite. Okay. I have given you better than that here on the board. Is that fine? You just write the title now. Now, in the next lecture, we will start with a small topic like this that will convert. Remember, we had done today angular distances, no? Latitude and longitudes are what? Angular distances. So for our Earth, we'll check that 1 degree of latitude would mean how many kilometers, and 1 degree of longitude would mean how many kilometers. It means we'll convert these angular distances into linear distances before we do something else. Okay, fine. So I'll stop here today, and I'll take leave from the online students too. Keep smiling, enjoy the process. We'll meet soon. Thank you very much.